Hi, my name is Rylee Blair.
I'm Striek.
And I'm Disha Mudenur, and we're from Hopkinton High School, and we invented the Dawsonite diver.
Stopping climate change is the most critical challenge facing humanity today. Ocean acidification will cause the collapse of the entire marine ecosystem, ultimately leading to grave consequences for all life on Earth. And that is why we have dedicated 7 months to creating the Dawsonite diver, a simple machine that will go on the back of boats, reversing ocean acidification and creating Dawsonite, a chemical compound that can be used as a fire retardant. We had the opportunity to talk to David Carroll, who is from the U.S. Navy, and he said that the Dawsonite diver will be beneficial for both the Navy and the planet.
In our over 8 notebooks, we've researched different methods of carbon sequestration, such as pumping ocean water underground and turning it into rock, or increasing the rate of calcium carbonate formation, or even just making more carbon products. However, big companies don't realize the harmful effects of drastic changes in the pH, the hefty amount of money this costs, and the gaseous products that are being emitted into the atmosphere.
But before we could create this final prototype, we tested the effect of time, voltage, and distance on Dawsonite production. After performing all of the complicated chemical equations such as half reactions, energy of the cell, and KSB values, we began our 3 months of trials. This diagram shows how we used graphite and aluminum along with a 3D distance measurer to keep the distance consistent while performing electrolysis. In the end, we found that 1 inch, 10 minutes, and 1 battery was the most efficient at producing Dawsonite, and these variables will be scaled up by 400% to produce a meaningful amount of Dawsonite in our final product.
Following the series of experiments, we successfully created a viable prototype that addressed the issues of carbon dioxide emissions without negatively impacting the environment. Through our developmental process, we meticulously went through each part of the prototype and made sure to keep in mind key criteria such as lightweight, aerodynamic ability for oceanic productivity, and self-sufficiency for ease of use.
Initially, we started prototyping with just paper and cardboard because this is what was available to us and it was very versatile. Then as we began prototyping our final prototype, we started to use 3D printed materials and plastic because this fit our structural and lightweight criteria.
Our final product is composed of pneumatics, a 3D printed exit mechanism, mesh, a filter paper rollable mechanism that collects the Dawsonite, graphite rods and batteries that perform the electrolysis, and this is all compacted into a 9 by 3 inch design that will ensure that the efficiency of a boat is not negatively impacted. As you can see here, you have the exiting mechanism and the rolling mechanism that collects the Dawsonite.
We have 3 main parts to our design: the entrancing and exiting mechanisms, the electrolysis, and the filtration system.
After this, we conducted 20 tests figuring out the efficiency, weight, and stability of different aspects. In one efficiency test, we tested to see what different shapes would make in pushing the water out within 5 seconds, and this one won, as you can see behind me.
We know the importance of talking to people in our community, so we started with our chemistry teachers during our experimental process, our engineering teachers during our design cycle, and a Coke executive who told us the importance of marketability. We also talked to Julie Curtis from Connected Alliances, who is the CEO, and Frank DiGiovanni, who is a senior officer at the U.S. Navy. They told us that we should figure out how much money our product costs to manufacture, which we calculated to be $13, as this would allow us to know how much we could sell our product for to the Navy, manufacturing companies, and even a common boat owner.
One problem we encountered through our process was the fact that the graphite rods were coming in contact with this pushing mechanism we had on our prior prototype. So we redesigned and came up with this spinning mechanism that was a lot more efficient, and that is what we included.
In the future, we want to make our prototype more aerodynamically favored because we want to make sure that the consumer, the boat driver, is able to attach this Dawsonite diver to the back of the boat and be unaffected. Also, the Dawsonite, since it can be used as a fire retardant, can be used in place of stuff like fire extinguishers and save month-long boat journeys time and money from searching for fire repellent and fire extinguishers, especially since it's literally being made on the boat.
In the end, we hope that this will curb the effects of carbon emissions by gradually increasing the pH of the ocean while producing Dawsonite for a good cause. The 11 million trips that cargo ships take, if this is attached to those cargo ships, will produce 2/3 of a shuttle for the amount of Dawsonite and $500,000 worth of profit for the users.
The Dawsonite diver is a carbon sequestration invention that prioritizes marine life sustainability, and self-sufficiency. With the Dawsonite diver, we aim to encourage more people to participate in ocean conservation efforts and create a positive impact on the environment for future generations.
Thank you.
Thank you.